Okay, so starting with the new chapter, chemistry, metals and non-metals. So this chapter, metals and non-metals, we have to study first the physical properties of metals, then chemical properties of the metals, that is chemical reactions of your metals. We have to see according to their reactivity series. Then we are learning how metals and non-metals combine. That means the ionic bond formation. We have to study how the ionic bond formation takes place. That we need to learn. And then finally, the extraction of few metals. In general criteria for extracting metals from their impure state. So chapter divided into three parts. First is physical and chemical properties of metals and non-metals. Then secondly, the bonding between the when metals combine with non-metals, the type of bond formed and how that bond formation takes place. Ionic bond formation we have to learn. And then finally, extraction of metals. Okay, so starting with chapter metals and non-metals. So what are metals and what do you mean by non-metals first? Few elements we call as metals and non-metals. So though these are categorized from a broad group called elements. You have learned last year, that is pure matter, first divided into pure substances and mixtures, right? Pure substances are
elements and compounds.
Elements and compounds. That is the substances which are made up of similar kind of particles, either atoms or molecules, similar kind of atoms or similar kind of molecules. So such compounds are called as, so such substances are called as pure substances. Now, if any pure substance is made up of similar type of atoms, then it is called as element. And if it is made up of similar kind of molecules, then it is called as compounds. So elements known to us, which are found in nature, not created, they found in nature, approx 118 elements are there till now. So those are broadly classified into four types. So first type is metal, second one is non-metal, third one is metalloid, and the fourth one is noble gases. So elements are further divided. Known elements. Elements are the substances which are made up of atoms. That means inside atom element, we can see only one type of atoms are present. These are further classified into four categories. First is metal. A large number of elements are present in the group metals. Then non-metals. Third is metalloid. And the fourth one is noble gases or inert gases. Okay. So all these four are categorized according to their physical as well as chemical properties. Right. Metals, you know, that is they have, these are the metals which possess elements which possess luster, are hard, rigid, high tensile strength they have, high density they have, high melting and boiling points they have, good conductors, good conductors of heat and electricity, sonority, malleability, ductility. So these are the properties, physical properties, whichever the elements possess. According to appearance wise, external appearance, whatever properties we study. So if these elements possess this property, so all those elements are categorized under metals. Okay. And exactly reverse properties, that means which are non-lustrous, non-rigid, not hard, low melting boiling point, low density, non-sonorous, non-malleable, non-ductile. So these properties, whichever the elements are present, are considered as a non-metals. Okay. What are metalloids then?
They have the characteristics
Ma'am, they
of
have
non-metal
combined
and
properties
metal.
of metals and non-metals.
Not okay. They have the
Properties which intermediate between metals and non-metals.
which are intermediate between metals and non-metals. Not good as these properties, whichever the metals and non-metal possess, they are good in both of them. In metals, they are very good, and they non-metals, they are not there. So metalloids are the substances, those have the properties in between metals and non-metals. So some of the properties they possess from metals, but not as good as metal. So they are intermediate. We can't consider them as all the properties of metals they possess. No. They have few properties of metals, but that too also not as good as metal. Just like when we see in case of electricity, current carrying capacity or heat capacity. So that is, metals are very good conductors. So they conduct current very fastly without less obstruction. They have resistance very less. They provide very less resistance, and non-metals provide more resistance. So therefore current won't flow through them. But in case of metalloids, they are conductors, but not as good as metals and not as bad as non-metals. So we call them as semiconductors. So we won't consider that as a good conductor or bad conductor. We call them as a semiconductors, poor conductors. So they conduct current, but under certain conditions. So therefore, these many other properties, density also in between metals and non-metals, melting point, boiling points in between metals and non-metals. If we can take the example, chemical properties also, if we take the example of acidity and basicity. So all the metals are basic in nature, non-metals are acidic in nature or neutral. Metalloids are in between. They're amphoteric, most of them. Okay. So the properties are intermediate between metals and non-metals. Rather than saying that is they possess the properties of metals and non-metals, they possess both the properties, but in between. Not too big as a metals and not too bad as a non-metal. Okay, so those we call as metalloids. Silicon, germanium, arsenic, polonium, tellurium are the examples of metalloids. And what are noble gases?
They do not react with like they do not take part in chemical reactions, ma'am.
These are the gases, these are the substances, metals, elements which do not take part in any chemical reaction. It is according to chemical property wise, these are categorized, not physically. Physical property wise, they look like they possess properties just like a non-metal. So it is earlier considered under non-metal category only, but after that they have been separated as a noble gases. The reason chemical property, according to chemical property wise, these gases do not react with any of the substances. So these are chemically inert, chemically non-reactive, noble. So therefore, these are called noble gases or inert gases, and they are found in gaseous form in nature and very traces, less amount. Amount of these in air is very less. So therefore, noble or inert because chemically inert, and gases they found in gaseous state. All of them, 6 noble gases are there. All of them found in gaseous state in air. So therefore, noble gases. Okay. So one by one, we have to see metals and non-metals. First, we will see the physical properties that you already know. According to physical property wise, difference examples. Physical properties, metals. So first, they are hard solid. Metals are hard solid. These are hard because of its more strength, more density, and as well as they are solid in state. Because of that, they are solid in state. But there are few exceptions. And these are found mostly in gaseous state. Only bromine is in liquid state. And if solid, are brittle. If found in solid, they are brittle or amorphous. Exception for this is sodium.
Mercury.
What?
A mercury is found in liquid state, right?
Yes, right. Sodium and potassium can be easily cut with knife.
Once gallium cesium comes to liquid state when kept in room temperature.
Yeah. Mercury, liquid state. Gallium and cesium, liquid state at room temperature or just above room temperature, they found in liquid state. Here found mostly in gases. Those are hydrogen, oxygen, chlorine, nitrogen, fluorine. These are in gaseous state. Any other? Liquid state, bromine. Amorphous, if they are in solid state. Some of them found in solid state, but they are brittle or amorphous. That is carbon, phosphorus, sulfur, iodine. And exception for this, diamond, allotrope of carbon. So that means diamond is an allotrope of carbon. Carbon found in nature in many different forms. Out of that, one is a diamond. Inside diamond, we can see only carbon. So therefore, it is called as allotrope. So carbon is hardest known substance. Diamond is the hardest known substance. More harder. Harder than metals as well. Any metal cannot cut diamond. Understood? So what are allotropes? Allotropes, few non-metals possess allotropes. So allotrope mean the element found in nature in different physical forms. That means inside that the atoms are same. Just like if we see carbon has no allotropes, one is graphite and the second one is diamond. Well known, there are many more. So graphite and diamond, inside if you see, outside it is, they completely look different. Graphite is grayish in color and brittle. Easily you can cut with your hand. Graphite pencil you are using. The lead of pencil is a graphite. You can easily break it into pieces. It is brittle. Just hammered it, it will break into particle powder form. Get converted into powdered form. So that much soft it is. And the diamond is hardest. Any metal can't be used to cut that. So inside that physically, although and that is appears shinier. So actually inside that, outside they oppose, externally they are completely different from each other. But both of them have a same element, atoms present inside them, that is a carbon. So inside diamond and graphite, Buckminster football is also there. Fullerene, it is one of them. Then it is a powder also, coke powder, which is a purest form of carbon as well. So these are also the different forms of carbon, existence of carbon. Carbon exists in these all different physical forms. So physically, although they are different, their physical properties are different, but inside that chemically, if we see, they contain only carbon atoms. Only the bonding between carbon differs there. And because of that, the physical appearance of those substances are completely different. But what is the definition of elements? Elements are those substances which contain similar type of atoms. So all of them similar type of carbon possess. All of them possess similar type of carbons. Only carbon is present inside them. So those are called as allotrope of carbon. Okay. Phosphor is also found in two forms, yellow phosphor, white phosphorus. Sulfur is also there. Sulfur also possesses allotropes. Understood what do you mean by allotrope?
Yes, ma'am. Yes, ma'am.
Physically, they are completely different, but chemically, they are exactly similar. That happens due to the bonding between carbon atoms. How the carbon atoms connect with each other inside that substance. That due to that, the physical property is different. Understood? So these exceptions, you know the properties, you have to remember the exceptions more. Then second, metals are ductile and malleable. And non-metals are non-ductile, non-malleable. So ductile and metals are ductile and malleable. That means ductility means
They can be drawn into wires.
they can be drawn into wires, right? So that means by hammering, by pressing them, the metals can be converted into thin wires, thin long wires. We can make them. And malleability, that means by hammering, we can convert them into
Thin sheets,
Thin
ma'am.
sheets.
thin sheets we can prepare from the metals by hammering because they are non-brittle. They won't break. After applying force on them, they won't break. They get pressed by hammering them. But non-metals are already very soft solids. That means they are very brittle and amorphous and mostly found in gaseous state. So we cannot convert them into wires or sheets. Then third physical property.
Metals have higher melting and boiling point.
Okay, they have high melting and boiling point. Metals are, okay, I was writing sonorous. High melting and boiling points.
Exception mercury.
Exception is mercury. And even lead. Lead also is, no, not lead. No conductor. Mercury. And here, third property is non-metals are non-sonorous. That means they won't produce ringing sound when struck hard. When we struck hard a metal, it produces a ringing sound. So that's the reason it is used as a metal in bells. Non-metals do not possess that property. And non-metals have low melting and boiling points. Then fifth one, they have high density.
Electricity and heat.
Yeah. Low density. Good conductors of heat and electricity, heat and current. Bad conductors of heat and current.
Ma'am, exception is graphite, right?
Graphite and diamond both. For heat, graphite is the exception. For heat and for electricity. For heat, good conductor of heat, diamond is a good conductor of heat. And electricity exception is graphite. And even here, I left. High melting and boiling point exception is cesium. Gallium and cesium. These are actually found in gaseous, solid state. But as soon as we keep them on our palm, they melt. Melt on palm. So that much heat energy is enough for them to melt. The next property.
They are lustrous in nature.
Yes, right. Metals are lustrous. That is possess shine. And non-metals are non-lustrous. Do not possess shine.
Ma'am, is there any exception?
No. Non-lustrous only this one. Diamond is actually non-lustrous. That it becomes lustrous because of its etching process. That is, it is carved such a way that it start reflecting light. And because of that property of reflecting light, it shines. It actually won't possess shine. It is just like a normal stone. When it is taken out from the mines, it is normal stone only. But it possesses luster because of its etching process. It is etched so much, every edges are carved so that it is at a particular angles. So due to that, we can see that is it reflects most amount of light. And therefore, it appears shiny, but it is not. Iodine. Iodine. Yeah.
For low melting point and boiling point in the non-metals, diamond has a high melting point, right?
Yes, right. Exception for non-lustrous is iodine. Iodine crystals are lustrous. Then high tensile strength. And no tensile strength.
There is an allotrope of carbon that has the highest tensile strength, right?
Tensile strength they don't have.
Mom, like it's an allotrope, like it's used in cables, mom. Carbon cables are there.
Carbon cables, that is your different one.
Okay.
Yeah, yes, right. So high tensile strength means bearing load without breaking. So if you place a load to them or apply load to those metals, they resist, means they hold that load without breaking. Just like you can see on iron girders, we generally buildings are constructed, high-rise buildings are constructed by using only iron rods. Bridges are constructed using iron rods. So iron rods are bearing that heavy load and they won't break. They won't break. So that is the high tensile strength. Just like a spring, at the end of the spring, when you connect a load, so it will hold that load without breaking. Will it break after applying a load? Cut into pieces?
No, ma'am.
No. So that means that property, that is a forming tensile force, creating tensile force in the threads. When anything rope, with the help of rope, when you are holding anything, so the force applied, the load is pulling it downwards, the gravitational force pulling that load downward, but something is there holding that load in upward direction against gravity. So that force is created by stretching the string. So that force possessed by the string while holding the load is called as tensile force. And that metals possess. That force metals can have. So therefore we can consider them as high tensile strength they have. Any other property left out? Is there any other properties?
Some colors.
Color generally grayish in color. Metals. Metals generally all are grayish in color. Or shiny, copper, brown. Non-metals possess different colors. But that cannot be considered because most of them are gaseous state. Okay. Any other?
Mostly no, ma'am.
No.
Mom, I was talking about carbon nanotubes, mom.
Yeah, nanotubes, right. Yeah. So already you have learned in class 8th. Continuation. Have you written this?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay. So here some of the points, write it down as a note. First thing, sodium and potassium are the metals can be easily cut with knife. Write it down, these points. Sodium and potassium can be easily cut with knife. Second, gallium cesium melts on palm. Low melting point. Gallium cesium have low melting point, so easily melt on palm. Third, mercury liquid metal. And bromine liquid nonmetal. Best conductor of heat and electricity. Silver. Poor conductors of heat and electricity. As mercury and lead. Lustrous nonmetal iodine. Iodine crystals. It is found in the form of crystals and which is purple crystals.
Ma'am, could you give the definition of allotrope?
Allotrope, the different forms of substance, different form of same element, which possess similar physical properties, similar chemical properties. Which possess similar chemical properties but different physical appearances and properties. But different physical properties and physical appearances. Done?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
And diamond is the hardest known element. It is a good conductor of heat, and graphite is a good conductor of current. That is also you can include. Okay. So everything you know, only thing you have to learn, remember, that is poor conductors of heat and electricity is mercury and lead. So all others you already know. Okay. Then
Yes, ma'am.
next is the chemical properties. Sorry, metalloids, and write about the metalloids and inert gases. Metalloids, elements with properties intermediate between metals and non-metals. Example, silicon, germanium, arsenic, boron, etc. And inert or noble gases. So these are elements in gaseous state are not chemically active or are not chemically reactive. They do not take part in chemical reactions. They do not take part in chemical reactions. Example, helium, neon, argon, krypton, xenon, radon. Done?
Yes,
Yes,
ma'am.
ma'am. Yes, ma'am.
Yes, ma'am.
Now next is chemical properties of metals and non-metals. Chemical properties, that is, we have to see the reactions. First thing about metals and non-metals, you have to remember that although there are exceptions, then still we consider some of the elements as metals and non-metals. Why? So that is because of its chemical property. So what is the main chemical property which differentiate these metals and non-metals? Although physically they are completely different, they do not possess some of the properties of metals. Now, why they have been categorized as metals? Just like you can say as a sodium and potassium. They are not hard, not much lustrous. They are lustrous, but not much lustrous. Again, melting points also somewhat less, because they generally, when we start heating, they will catch fire. So we are not able to understand that. So properties of metals, malleability, ductility, we can't see in sodium and potassium. Then why we are categorizing them as a metals? Because of its one main chemical property. That is, generally metals have electronic configuration. We have to see. If you check the electronic configuration of metals, what you will observe? If you see the electronic configuration of elements, what you will observe in metals? So known elements to you. Examples of elements. First tell me examples of metals, well-known metals.
Sodium,
Sodium, calcium,
Sodium,
magnesium,
magnesium,
aluminum.
aluminum.
Magnesium, aluminum.
We will write
Ma'am,
here. metals.
Ma'am, in their electronic configuration, they'll have like 1, 2, or 3 electrons as left out in the outer shell, ma'am.
Yes, so here it is sodium, potassium, magnesium, calcium, aluminium, zinc, iron, copper, mercury, silver, gold, platinum, then again lithium, barium. Okay. So the known ones. And examples of non-metals are carbon, nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine, bromine, iodine, etc. Okay. So now if we see the electronic configuration of metals, the known ones. Sodium, if we see, sodium atomic number is 11. So it is 281. Potassium, atomic number 19. So it is 2881. Magnesium, atomic number 12. 282. Calcium, 20. 2882. Okay. Lithium, 21. Okay. So most of the metals you can see, and aluminium, 13. 283. Right. Beryllium, 2. So most of the metals, not all of the metals, they have in the outermost shell, that is valence shell, the valence electrons are either 1, 2, or 3 electrons in their valence shell. So metals are those elements in which atoms, they have 1, 2, or 3 valence electrons, not more than that. So therefore, they have a tendency in chemical reactions, they have a tendency to lose electrons because they have 1, 2, or 3 electrons. So they can't gain electrons, because if they want to gain, they have to gain 5, 6, and 7 electrons, which no one will give that. So therefore, they can't gain electrons. They have a tendency to lose electrons, and after losing, they become electropositive. They form positively charged ions, so they are electropositive. Right? So metals are those elements which are electropositive in nature. That means they have a tendency, they have 1, 2, or 3 electrons in their valence shell, and therefore they have a tendency to lose electrons rather than gaining. So therefore, these are called metals, and the opposite is non-metals. If we see the electronic distribution of non-metals, non-metals have 5, 6, or 7 valence electrons. So therefore, they have a tendency to gain electrons and form negatively charged ions. That means electronegativity they show. They show the property of electron. They are electronegative. That is, they have a tendency to form negatively charged ions in chemical reactions. Able to understand? So because of that property, although they possess some exceptions according to physical properties, but they are categorized as a metals only and non-metals only. That is because of this electropositive and electronegative nature. So metals and non-metals. Metals generally possess one, two, or three valence electrons. Electrons which are present in the outermost shell are called valence electrons. An outermost shell is called valence shell. Valence electrons, hence they have tendency to lose electron and form positively charged ion. Positively charged ions. Therefore, metals are electropositive. And exactly opposite in case of non-metals. Non-metals generally possess five, six, or seven valence electrons. Hence, they have tendency to gain electrons to form negatively charged ion. Therefore, non-metals are electronegative. Now you tell about the carbon. The carbon has 4 electrons. Then how it is non-metal? Hydrogen is the exception. Hydrogen is both. It can lose also and can gain also. So therefore, hydrogen we can compare with the metals as well as its non-metals. The thing is why we are, because generally what happens, metal and non-metal combines together, then only they will either lose or gain electrons. But when the elements are electronegative, they have a property to share electrons. That is forming the covalent bonding. So two electronegative elements only can share electrons and complete their octet. So carbon has that property. Carbon can't lose or gain electron. It only shares electron. So that means by sharing electrons, if it is fulfilling its valency, that means it is covalent bond. It forms the compounds always covalent bonding, not with ionic bonding. By losing or sharing electrons, it won't form compounds. It will form compounds only by sharing of electrons. So therefore, carbon is considered as a non-metal. And if under high pressure and high temperature, if it is allowed to lose or gain electrons, it has a tendency to gain electrons rather than losing. It can form carbide. Metal carbide can be formed. It can't lose electron, but it has a tendency under high extreme conditions of temperature and pressure. Carbon can combine with other elements and form negatively charged ion. Therefore, it is non-metal. It is categorized under non-metal. Clear? And hydrogen has a property of both losing also. Sometimes it will lose, sometimes it will gain. Yes?
Yes, ma'am.
Okay. Clear? Except carbon and hydrogen, all of them either have 5, 6 or 7 electrons, and they have always forms negatively charged ion. And even hydrogen also, by sharing electrons, it can complete its duplet. So it also can form covalent bonding. Therefore, hydrogen is a non-metal. Okay, clear?
Yes, ma'am.
Yes, ma'am.
Written this, metals and non-metals, chemical property, first.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Now next we have to learn the reactions of metals with oxygen, then water, acids, and other metal compounds. Okay, four types of general reactions we have to see. So first reaction with oxygen. Both metals and non-metals can react with oxygen. So chemical reactions. First one. Reaction with oxygen. So metals react with oxygen and form metal oxides. Every metal can react with oxygen and form metal oxides under different conditions. Some reacts very vigorously depending on their reactivity series. Some reacts very vigorously with oxygen. Some reacts with less vigor. Some reacts only on heating. Some reacts only on strong heating. But they generally react. So sodium and potassium, as soon as they generally stored under kerosene or oil, as soon as we bring that this element outside the kerosene or any oil, then immediately they react with oxygen vigorously. This reaction is very vigorously. So sodium combines with oxygen and forms sodium oxide. So it is 2, 4, Na. Vigorous. Similarly, potassium 4K plus O2 forms 2K2O. This is also vigorous reaction. Calcium combines with oxygen but with less vigor. Just like we are seeing the reactions with reactivity series wise. In the reactivity series, potassium, sodium, then calcium, then magnesium, then aluminium, zinc. So according whatever the reactions of metals and non-metals right now we are seeing, all of them are we have to study according to their chemical reactivity. Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper below that. Mercury and then copper and then mercury is there. So we are studying copper, iron, zinc, aluminium, magnesium, calcium, sodium, and potassium. So in the reactivity series is formed by these whatever the reactions we are seeing, accordingly they have been formed. We know that is sodium and potassium reacts very vigorously. So they are at the top. They are most reactive. Then calcium combines with oxygen and form calcium oxide. Less vigor. Magnesium ribbon, you have seen, we have to burn it. It is a burning process. It burns. We have to heat it, then only it will burn. Magnesium plus oxygen. When we provide heat, then only it will form magnesium oxide.
Ma'am, but in general atmosphere also it oxidizes, right?
Yes, slowly oxidizes. Yes.
Okay.
The temperature when increases, it will combine with oxygen slowly, atom by atom. But every atom by atom combination takes place, which is a very slow process that we call as corrosion.
Yes, ma'am.
But if we want the full magnesium has to react and form magnesium oxide, we have to heat it. We have to heat that, then only it will combine with atmospheric oxygen and then forms magnesium oxide. Aluminium also, after strong heating, combines to form aluminium oxide, Al2O3. Or slowly it will combines with atmospheric oxygens layer by layer, atom by atom, one atom combines with oxygen. That is we call as corrosion of aluminium. Iron also combines with oxygen and form iron oxide, which is a here iron react with oxygen, but it will form a compound Fe3O4. Now, what is Fe3O4? You have a two iron variable valency, iron with valency 2 and iron with valency 3. So which compounds are formed by that? Oxygen is 2. So first compound formed is FeO, and the possible second compound is Fe2O3. Then from where Fe3O4 came?
Ma'am, when both combines.
It is a mixture. Fe3O4 is a mixture. It is not a compound. It is a mixture of both FeO dot Fe2O3. And copper. Copper also, when heated strongly, get coated with black color copper oxide. Shiny brown metal, when heated strongly, then only it will get coated with black color copper oxide. And this is also heating. This is also heat. This is also by using heat. Without that, they won't combine. Slowly reaction will take place atom by atom. But the full aluminium oxide formation needs heating. For calcium, potassium, sodium, they won't need. They can easily combine. Clear?
Yes, ma'am.
Yes, ma'am.
And the amount of heat needed to particular element to combine to form oxide. So that will change. Some need less, some need more. Accordingly, this reactivity series wise, their position is fixed. Their position in the reactivity series because of all these reactions, how vigorously they react and how slowly they react, or which way need more energy to get heated to combine with particular element. So according to that, this reactivity is decided. Clear? Now you
Yes.
know the
Yes,
property.
ma'am.
Yeah, fine. So here, you know the properties, that is all metal oxides are
Basic.
basic in nature. All metal oxides are basic in nature, but few of them are amphoteric. Which of them?
Aluminum, lead, and zinc.
A2.
Aluminium, zinc, lead, tin. Okay. So these are amphoteric. Oxides of these are amphoteric in nature. Now at this place in NCERT about amphoteric oxides explained. I have explained you already earlier.
Yes,
Right?
ma'am.
You remember that?
Yes,
Yes,
ma'am.
ma'am.
Now here in this chapter they have explained about amphoteric nature. All metal oxides are basic in nature. But zinc, aluminium, lead, tin possess or react with both metal and both acid and base to form salt and water. Hence possess both, hence show both acidic and basic behavior. So these oxides are called amphoteric. Understood?
Yes, ma'am.
Yes, ma'am.
Okay, fine. So now we'll start maths.